So good morning all of you. Here you can see that the today's topic is laws of motion. Okay, so first of all let us discuss motion. Okay, my first question is why body is said to be in motion, and the second question is why the body is not in motion. Right, two question can be arise. You may also ask, right? So, for the answer of the first question is we can say that if the body changes its position from one place to other place, so we can say that body is in motion. Similarly, the body will not change its position with the time. So we can say that the body is not in motion. Okay. So to put the body is in motion, we have to apply the external force. Like you can see in the picture also that when you are throwing the ball, you are actually applying the force, right? The force applied by you is an external force, not inside the ball. When you apply the force, when you throw the ball, it changes its position from your hand to the other place. Similarly, the boy is playing with the, and he is just pushing the car so that it can move to the other position. Similarly, you can see here in the trolley, right? In the mall, shopping malls, you always go and you push or pull the trolley, right? To put what the items you purchase from the mall. So, to understand this chapter, the laws of motion, let us have a quick recap on what we already doing. Okay, so you can see here, motion in the simple tendency is to the move, right? So, motion is required to move the object, right? An object is said to be in motion when it changes its position with time, as I said. And similarly, body can be in rest if not moving. That's it. And third thing is external force is applied. Okay, to put the body is in motion. Okay, so let us see, there are two types of forces can be possible. External forces can be possible. One is contact and one is non-contact. Okay, so what can be the contact force? As the word suggested, the contact means touch. So external force come into the picture when the body starts moving or comes to the rest, either by coming in contact with the body or without being in contact. All right, so contact force is the force which is applied by in contact. Okay, let us say the hitting of the cricket ball with a bat, right? Bat is in contact with the ball, so that ball can move. So we can say that ball is moving, ball is in motion due to the bat, right? Non-contact, the force applied without coming in contact. Okay, for example, the magnetic force, right? When you apply the magnetic force, when you put the magnet nearby the metallic object, it gets attracted. So that is what, without touching, the body gets pulled towards the magnet. Okay, so here is the Aristotle's fallacy. Actually, a fallacy. Aristotle was the scientist, right? A Greek scientist, held the view that the external force is required to keep body in uniform motion. Right? Aristotle was the person who looked at by doing several experiments that the body can be moved, body will be in uniform motion. Okay, when external force is applied. His concept is absolute now because he considered only one side of the motion and fails to explain the other. Right? That is, if the body is in motion, then how does it come to rest? Okay, he only simply says that the body is in motion, but he didn't explain about the rest. There came to the concept opposing external force of frictions. He only discussed about the force which is applied so that the object can move. But what about the other type of force which has a tendency to stop the moving object? He is unable to explain that. He was unable to explain that, right? That's why it is known as Aristotle fallacy. falls, right? For example, a rolled ball on the floor come to the rest after some time due to opposing the force of friction. So you can see the three balls. So in the first condition, ball is moving. In the third condition, after some time, ball become in rest. Ball stop moving. So we can say that external force is required to keep the body in motion only if resistative force are present, or that is called frictional force or viscous force. Frictional force is applied between the surfaces, and viscous force is applied between the water surface. You can see, right? Now there is another term, inertia. What is inertia? Again, inertia is the resistance of the body to change its state of motion. Okay, inertia is a type of force, you can say, that is resistance of the body to change its motion. So body at rest want to be in rest, body is in motion want to be in motion, right? You must have experience in vehicles, right? You have you experienced the jerk? Yes, you must have do that, right? There's a jerk. This happens because initially the car was in motion and the body was also in motion. Later, due to the application of the brakes, when you apply the brakes is applied, car come to the rest. But the body, due to the inertia, still want to be in motion. Therefore, the body does not come to rest once and experience the jerk. that's that's the reason. Due to inertia, you feel the jerk. Now, next is Galileo's laws of inertia. Galileo was a person who falsified the Aristotle law that we have seen. That okay, and he corrected the Aristotle law by saying that external force is required to keep a body is in motion only if resistative forces are present. Means external force is required to keep a body in motion only if the resistive force are present. Okay, so according to his law, a body moving on a frictionless surface should move with a constant velocity. A body at rest is considered equivalent to the body in uniform. And Galileo's this was the first law of motion on the basis of Newton's first law. Galileo's law came into existence, right? So in case of acceleration 0, net force is 0, so body will be in rest, right? Now next, see Newton's first law. Newton's first law says that a body is at rest tend to remain at rest, a body in motion tends to remain in motion in the state of uniform motion until or unless an external force is applied on it. Okay, so this is the Newton's first law which comes into existence from Galileo's also. Okay, for example, this law is also known as law of inertia. For example, a ball is lying on the table, you can see in the picture, at rest, at remain at rest. When you apply the force, body, see in the next picture, ball is start moving and can fall down or anything. Okay. Now, there can be another type of forces, balanced and unbalanced force, right? So balanced force is what equal and opposite force don't cause any change in motion. That is called balanced force. And unbalanced force is what unequal forces. Okay. So unequal forces applied can be in the same or opposite direction and cause a change in the motion. Unequal force example, you can see that what table tennis, you can see the player playing in a table tennis court. Player used to play the what tennis or badminton. So it depends on the what? It depends on the force that they both of the two are applying on the cock or the ball, right? If they apply the equal and opposite force, equal force from the both side, what? There will be no what we can say, points will be given to the any of the team member. That is what an example of balanced force. And unbalanced force, again in the same situation, it can be if there is an unequal forces applied and in opposite direction, so that the team can get a point, okay, and can win the match, right? So it's about this type of forces only they used to play. Now you can see tug of war also you must have played. Let's say a team 1 has a 4 member and team 2 has 3 member of equal weighted. So it's obvious team 1 will win, right? Similarly, if the both of the team have the equal number of people, so no one will win, right? Now let us see the another term which is called as momentum. So Newton's first law was for scenario that net force is zero, right? So the second law is for the scenario with the net force not equal to zero, right? First law says that when a net force is zero. Second law is the when net force is not zero. So momentum plays an important role. Let's see. Momentum is the product of the mass of a body and its velocity. It's a vector quantity. It's denoted by P equals to mv, where P is the momentum, m is the mass of the object, and v is the velocity. For example, a ball is applying with a 10 meter per second velocity, having weight 1 kg or mass 1 kg, has a momentum 10 kg or kg minute meter per second. So momentum of the system remain constant. Therefore, greater force is required to set a heavier object in motion. Okay, so greater force is required to stop moving object with higher velocity. Understand this statement. Greater force is required to stop the body moving with higher velocity. So more force is required to stop the body which has a higher velocity. Okay, so greater the change in momentum in a given time, greater is the force that needs to be applied. The momentum is what in momentum, the more time you give, the greater is the force that you need to apply. Understand? So in other words, we can say that greater the change in momentum, greater is the force applied. Alright, so I hope this is clear. I'm just concluding here. In the next video we'll start the Newton's second law. So I hope you understand this. Thank you so much.